Now let's look at figure 7-9. It deals with unbalanced current flow in a delta system. Now notice we're looking for L1. We don't know what the amps are there. And notice L1 is 70 amps. L2, which would be B phase, is 100 amps in the windings. And then, of course, you know L3 would be 90 amps in the windings, say. Now, what would the unbalanced current be, say, in L1 is what we're looking for. So the formula that we would use would be A is equal to the square root of B squared C squared plus BC. So looking at the formula then, you would have in B 100 amps, you'd have in C 90 amps in the winding, and then you would have 100 times 90. So we would come up with 10,000 plus 8,100 plus 9,000. Now when we do our math, that'd be 27,100 in the square root, as you see in the boxed in information, trying to find the current in L1, we'd come up with 164.6. So that would be the current in L1. As you see, it'd be 146.6. Now we could find B by the formula you see there. It would be in the square root A squared plus C squared plus AC. Now to find C, we'd have A current squared, B current squared plus AB. Now this is the procedure that we would use to find the unbalanced current in a delta connected system where your winding current is 70 amps for A, 100 for B, and 90 for C. And when you do your math in the boxed in information, then this at figure 7-9 is illustrating the calculation procedures and how we would derive 164.6 amps, the unbalanced current flow.